Hi, everyone. Thanks for coming to today's webinar. It's about AWS RoboMaker. My name is Ray Zhu. I'm a Senior Product Manager on the AWS RoboMaker team. Now, before we get started, we have a pretty critical question for us to answer is what really is a robot? Because robot means different things for different people. Some of you might be thinking about a humanoid robot when we talk about robot. Some of you guys might be thinking about a vacuum cleaner at your home. But to us, to AWS RoboMaker, robot really is very general. And for us, it means anything that senses, computes, and then actuates. So if you look at this diagram where you see all types of different robots that operate in the world today, it could be a drone that flies in the air, could be the robots operating the oceans, could be a robotic walker, it could be a self-driving car, could be these development kits for educational purpose, could be the Mars rover, and could be the arms working on a manufacturing line. Now, the inspiration for us to start the RoboMaker service was really from our internal teams, because Amazon as a company has been using robotics in our core business for quite a while now. And the famous ones are these orange Kiva robots working at fulfillment centers, and also the drones with Prime Air. When we start talking to these internal Amazon teams and also external customers, we see a pattern in terms of robotic development lifecycle. For all of these robotic hardware devices, they are powered by a software application, which is called Robotics software application that's used to control the sensor to sense the data, do the compute and calculation, and eventually control the actuators in the robot for movement. Now, this diagram shows the end-to-end development life cycle of typically what people need to do to build a robotic software application. First, they need to select a robotic software framework to build their application on. A robotic software framework is basically a middle layer on top of an operating system that abstracts away a lot of the common problems in robotics application. Now, once they pick a robotic software framework, then they will start developing their applications typically in an IDE or an integrated development environment. Then they will use testing and simulation mechanisms to make sure the application works as intended. And eventually, step 4, they have to deploy that application onto a fleet. Now, it's worth noting that step 2, 3, and 4 are an iterative process as robotics developers update their application and add more features to the robot. Now, from the previous slide, I talked about robotics software framework, the middle layer. And today in the community, there's something called Robot Operating System, or ROS. One thing to call out is ROS is not really an operating system. It's a software middleware that runs on top of Ubuntu Linux. It's basically at the core of the ROS framework. It's a message passing mechanism, supports multiple platforms, and it's open source under the BSD license. The ROS software framework is the most popular framework used today in multiple use cases in different areas of the community, including academic and commercial use cases. Now, a pattern we've seen as we spoke to these customers who are trying to build robotics applications is it's pretty hard to build a robotics application today. To build any intelligent or powerful functionalities, you need to have a lot of expertise and skills in machine learning. It is very time-consuming and costly to set up a development environment, to run simulations for testing purpose, and it's even harder to scale the infrastructure for running large-scale and parallel simulations for testing purpose. Also, there's duplicated effort involved when you want to deploy the application onto the robotic hardware. Now, as we discover these common problems in robotics development, that's why we did AWS RoboMaker, is to solve all these different type of problems. Now, before I dive into what is AWS RoboMaker, I want to share with you guys about who's using AWS RoboMaker, who are our customers. As you can see from this slide, across different industry segment and company sizes, these customers are all using AWS RoboMaker in their core business. For example, Sony Aibo developed the robotic dog as companionship at homes. Apex AI is developing a self-driving car. Stanley Black and Decker, they're in the construction business. They built a autonomous drone and ground vehicle to take sensor and LiDAR data from the construction site and then build a model for virtual inspection purpose, which will dramatically improve the worker safety for folks who need to do on-site inspection previously. Leah from Robot Care System, they built a robotic walker that's used for elderly care and for disabled people to be able to freely move around. It's an autonomous vehicle that can navigate towards you for use, and once you're done with the walker, you can send it away for charging itself. And also there's NASA JPL who did a demonstration with RoboMaker at the embargo session at re:Invent, using RoboMaker to easily build an arm that can mimic a human behavior from the camera stream. And that arm was mounted on top of a open source Mars rover robot. So these are just a few examples of the customers in different industry segments with different company size using RoboMaker to innovate in the robotics space and to improve their business and customer experiences. Now, let's get into the core of the content. What it really is RoboMaker. RoboMaker is a service. It has 4 independent yet integrated capabilities. It has a development environment in the cloud for application development. It has cloud extensions for ROS, which extends the robot operating system framework to connect to AWS services for building intelligent and powerful functionalities into the robots. It has a simulation as a service and also fleet management capability for over-the-air deployment. Now let's dive into each of these 4 capabilities one by one. First is a dev environment. For those of you who are developers or robotics developers, oftentimes you realize actually before you can start writing the first line of your core robotic software application code, you need to spend hours and sometimes even days to do the tedious setup work. You need to provision infrastructure or purchase a dev desktop. You need to download and install an operating system, the robotic software framework, make sure all the toolings are properly configured and they work together. These are just waste time and effort. And for a company with dozens or hundreds, even thousands of developers, these wasted effort, they add up really quickly. And as a result, what you lose is time for innovation, critical dev time for innovation. So that's why we built RoboMaker Dev Environment. It's based on the AWS Cloud9 service, which is cloud-based IDE. From this diagram, you can see that in the middle, at the center of this diagram is the AWS Cloud9-based RoboMaker Dev Environment. It's integrated with ROS, so it's pre-installed along with our build and bundling toolings. It has integration with cloud extensions and some of our sample applications, which I will touch up on a little bit more later on. It also has integrations with different RoboMaker capabilities so that you can actually do everything you need to do from the RoboMaker dev environment through a single pane of glass. Now, I want to show you how the RoboMaker dev environment looks like. So this is the AWS RoboMaker console, and for now we're just going to look at the dev environment. It's super easy to create a development environment. You will give a name and you will pick the right instance size. So you can pick whatever instance size that you want to use for your application development. So depending on the type of the application and complexity of the application, you can pick the right instance size. You can also put a VPC, assign a VPC to that instance for communicating with other AWS resources that you own. And afterwards, you just click on the create button, then the dev environment will be automatically created for you. And minutes later, it'll be up and running. And for this demonstration purpose, I already have a dev environment created called row_RoboMaker. And if I click on open the environment here, it'll bring me here. So it's a fairly familiar interface where you can see the structure of your application project on the left nav panel. And in the main panel, you can write and edit your code here. What I'm showing is basically a rotating ROS node, which is part of the ROS robotics application for one of our sample apps. And you can do command line. And then on the top of the menu bar, you can see in addition to these generic AWS Cloud9 IDE capabilities, we also have integrations with other RoboMaker capabilities. For example, here you can trigger the local build tool to build the application, bundle them, upload them to an S3 bucket, and then later on launch a simulation with RoboMaker for testing. And you can also create a workflow so that you can chain up these different activities, and you can just launch a workflow to trigger, for example, a rerun of a simulation with updated software code. So this becomes really handy during iterative development. And you can also launch the simulation panel directly from this dev environment so that you do not need to go to RoboMaker console, and you can do everything from development, building, and simulation from the same interface. And of course, it's also integrated with some of our cloud extension capabilities and sample applications, which I will dive into more details later on in this webinar. Okay, so that's a quick show of the dev environment. Now let's move on to the cloud extensions for ROS. So as I mentioned previously, ROS is the most popular software framework today customers and developers use for robotics application development. Now, among all the customers we have spoken to, almost every single one of them would love to add more powerful and intelligent functionalities into their robot. However, they couldn't quite do so previously because they were constrained by two different things. Number one is the local compute and memory resources on the hardware device of their robot. A lot of time, it's intentional to keep these resources limited on the hardware device to keep a reasonable cost structure, but that really limits what a robot can do because of this local resource constraint. Second one is expertise, because robotics, as I mentioned, is an extremely hard problem to solve. And in addition to robotic systems, for a developer to build intelligent functionalities, for example, like facial recognition, he or she also needs to know a lot of different areas of machine learning, which is pretty hard for a single person or a single company to possess all of these skills that are necessary to build these different kind of intelligent and powerful functionalities. That's why we built RoboMaker Cloud Extensions for ROS. We want to bring the power of AWS services onto the robot device and make it easy for every robotics developer to use AWS services to build intelligent and powerful functionalities into their robot. Today, we offer 5 different cloud extensions for the ROS software framework. We have Amazon Lex and Parley extensions so that developers can build things like voice command control or chatbot functionalities into their robot. We provide Kinesis video streams extension for developers to do live video streaming of the robot to a cloud environment or to a mobile device. And if you pair that with the Amazon recognition extension, then you can do very interesting things like object detection or facial recognition. Then we also have the CloudWatch extension for logging and monitoring capability to offload telemetry and log data from the robotic hardware device to the cloud so that it can get more insights into the robot fleet. Now let's take a look at one of the extensions so that you can get a sense of how they work. So in ROS, the application is constructed by 2 main concepts. One is called ROS topic, which is the messaging bus in the ROS core, and the node you subscribe to the message bus is called a ROS node. So every single of the RoboMaker cloud extensions are written as ROS node. So you can easily incorporate that into your core ROS applications. It'll automatically load the message from the topic you subscribe the node to and create a secure connection to the relevant AWS services and continuously stream data and make API calls to these cloud services. Now, For all of these different cloud extensions, we provide 6 sample applications today so that you can see how these cloud services can help you to build very interesting and powerful robotics applications. We have a Hello World application, which is introductory for you to learn the concept of RoboMaker. We have robot monitoring application where we're using CloudWatch service, and the robot will continuously offload metric data like speed of the vehicle, distance to the closest obstacle into CloudWatch so that you can see near real-time monitoring metrics from Amazon CloudWatch. We have navigation and person recognition, where that robot will use Amazon Kinesis video streams to do live video streaming into the AWS cloud, and then use Amazon recognition to recognize the persons from the video stream. We have voice commands app, which is using Poly and Lex. You can actually use voice command to control the movement of the robot. You can do things like move forward, move backwards, turn left, turn right. We also have a self-driving sample applications using reinforcement learning, where that simulation, that application will actually teach a car to drive autonomously using reinforcement learning algorithms being trained in Amazon SageMaker. We also have object following application where there were 2 robots operating in the environment, and the first robot will just navigate autonomously in the environment, and the second one will try to look for the first robot and then follow that robot again using reinforcement learning, and the model is trained in Amazon SageMaker. Okay, so that's cloud extensions for ROS, and we also provide these sample applications. And now let's talk a bit about simulation. So simulation is extremely popular and widely used in robotics development. The reason is because it's extremely hard and costly to do tests on real hardware, which is why simulation becomes very handy, where you can model the 3D virtual world and model your robot so that you can test your application in a virtual world versus in the real world. We have seen 3 main simulation use cases so far from our customers. The first use case is used as a testing tool during iterative development. So when the developers are still building the application, they can use simulation as a testing tool and do very quick iteration to see whether their code, their application works as intended. So this way, every single developer can just easily and quickly use a simulated world and use a simulation job for iterative testing versus having a hardware device for every single developer. The second use case is for regression testing. So before each new software application release and deployment, we often see customers using simulation to test different scenarios for a particular application to make sure the updates still make sure the application works properly with these new updates. For example, one of our customers, before they use RoboMaker Simulation, they do software application release every 3 months. And out of the 3 months, they had to spend 1 month just for testing purpose, because they have to test that robot in the real world in different scenarios, in different rooms with different environmental noises and variances, which was very time consuming to do. And with simulation, you can just model these different kind of environmental variance and noise, different worlds, in a 3D virtual world, and then run multiple simulations to test these different scenarios and make sure the application still pass certain performance threshold and criteria. Now, the third use case, which I touched a bit on when I introduced these sample applications we provide, is for machine learning model training and algorithm building training. Is if you think about, in order to train a machine learning model, if you want to do that using real world data, it's extremely time consuming and costly. With simulation, you can actually start multiple simulations in parallel and to train a single model. So that way you can achieve the training results much, much faster. And what's even better is in the simulated world, when you run a simulation job, it can run faster than real time. So for example, let's say 1 hour in the real time in the human world, it might be able to run 3 hours, 4 hours, 5 hours, or even more in the simulated world. Again, that really helps you to achieve faster training, which I will show you a demo a little bit later. Now, this is the architectural diagram about RoboMaker simulation capability. At the center of the diagram, that's RoboMaker Simulation. It runs on an instance that's managed by RoboMaker, so you do not need to manage or scale any infrastructure. On the left-hand side, we provide a variety of toolings for you to interact with the simulation job, and that's really for the first simulation use case I just mentioned for iterative development. You can visualize how the simulation world looks like, how the robot operates in that world. You can visualize sensor data so that you can have a view of the robot, which is very handy for troubleshooting purpose. You can visualize the message passing between your ROS node for debugging purpose, and you can also use a terminal to use command line to interact with the simulation job while it is still running. On the top right-hand side of the diagram is the way you will create a simulation job is by uploading a robot application and simulation application into an S3 bucket. Then you will create a simulation job with RoboMaker. Then we will run that simulation job for you and grab these two applications from your S3 bucket. A robot application is basically the application you will eventually deploy onto the robot. The simulation app contains the 3D virtual world and the plugin to control the virtual robot to drive in the simulated world. Now, on the right-hand side, we also provide CloudWatch metrics and also logging capabilities in both CloudWatch Logs and Amazon S3. And these capabilities are really handy for regression testing and model training use cases where you will spin up multiple simulation jobs and run them concurrently and maybe for hours or even hundreds of hours. And most likely you will not want to stare at these simulations while they're running. Instead, you will emit metrics and logs from these simulation jobs so that once these jobs are completed, you can just look at the metrics to see how they've operated. And if you notice anything didn't work as intended, you can then go to logs and dive deep into figuring out what went wrong, and then you can troubleshoot and then fix code and then run it again. Now I want to show you the simulation and some of the sample applications, one of the sample applications I just mentioned. So again, let's go back to the AWS RoboMaker console. I talked about the development environment. So I also introduced a robot application, what you will eventually deploy onto a robot device. You can create a robot application with a RoboMaker. And when you do that, you give it a name, choose the software framework, and you can provide multiple sources pointing at your S3 bucket. We support different architectures. x86 is normally what you run the simulation for, and depending on the type of hardware you use for the real robot, you might be using x86 or ARM architecture, so you can store multiple architectures of the same application with us and create them as a robot application. Simulation application is where the 3D model is stored and also with the plugins to control the models to move. It's very similar to the way you will create a robot application. So you will select the simulation engine, version, rendering engine, and similarly, you will point at a source file in an S3 bucket. And as I mentioned, RoboMaker Simulation runs on x86 architecture, so we will only have one architecture and one source file for the simulation application, as opposed to multiple source files for the robot application. So now simulation job, as I mentioned, if you go to the sample application page of the RoboMaker console, these are the 6 sample applications we've pre-built. And all of these sample applications not only come with a source code that you can view and modify and build on top, they also come with a sample simulation job so that you can just pick whatever sample application you're interested to see how they work and learn about, and then click launch simulation job, then you can see how they work in the simulated world. Now in this case, I already have a sample application, which is the reinforcement learning model for self-driving, launched and created. I'll just quickly show you how they look like and what you can do with it. So as I previously mentioned, we provide multiple tools, Gazebo, RQT, Arvis, Terminal. These are just different tools in the ROS ecosystem for you to interact with the simulation job. So if we launch Gazebo, you will be able to see this is the live simulation that is running. You can see actually there is a car, if you can see at the bottom right corner. Let me see if I can drag and drop that car to the racing track. Let me get it back to the racing track, and you can see actually that car is driving in a virtual environment. It's using reinforcement learning model behind the scene, and the car will drive on the track, off the track, and depending on the score system defined in the machine learning reinforcement learning model, the car will reset itself and then keep learning until it knows how to drive within the track. Now, in addition to this simulation worldview, you can actually also use, for example, the RQT tool, which you can visualize the sensor data. So in this case, I've picked the camera view of the robot. Let me drag and move the car into the track, and you can see a camera view of this car. So now you can see what you're seeing right now on the right-hand side is actually what the robot is perceiving, which is the camera view. So let me try this again. And you can see basically this is a racetrack and a camera view. And the robot is basically using the camera input to train the machine learning model and figuring out whether it's driving on the track or not. So that's a quick demonstration and overview of the simulation capability in RoboMaker. And again, we have these multiple sample applications. You can easily choose one of these or try multiple of these to play with them in the simulation job. And then you can actually access the source code. Let me go back to the development environment, and you can actually access the source code from the development environment. You can pull down these different sample application source code, and then you can actually look at how the source code works, and you can make changes to it, rebuild it and bundle it and rerun simulation and see what kind of cool functionalities you can add to these pre-built sample applications. Okay. Now let's go back to the presentation. So as I mentioned, for regression and machine learning model training use cases with simulation, that really requires you to run very large scale and parallel simulations. And this diagram really shows the powerful combination of simulation and the infrastructure in the cloud. You can only do that in the cloud where you want to run, for example, say 500 simulation jobs for 10 hours. It's almost impractical or economically impractical for you to do that with your own infrastructure. But with RoboMaker Simulation, you can do that, and we will manage all the infrastructure scale for you, and you only pay for what you use. This is a quick video, so if you still recall the sample simulation job I just showed you. In this case, we've launched 5 simulation job at the same time, having the same robot application, driving 5 different tracks, and all of these 5 different simulation jobs are training the same model in SageMaker. So this way you can actually not only learn 5x faster compared to just running one simulation job, but also it incorporates different environmental variances because these tracks are different. So a quick video to show you can basically see the red car is moving from these different tracks, and behind the scene is feeding data into SageMaker and train the reinforcement learning model. Again, that's leveraging the parallel simulation capability and the large amount of infrastructure resource at AWS and at RoboMaker. Okay, Now we've talked about the cloud-based dev environment. We talked about cloud extensions to help you build intelligent and powerful functionalities into your application. We've talked about simulation for testing and model training purpose. Now you've got everything done. You've got the application. It's been fully tested. You want to deploy that application onto your robot fleet. And again, we think building a deployment system or integrated with an existing system out there is undifferentiated heavy lifting. And we'd rather manage that for the developers so that the developers can focus on innovating their core robotics applications. So at a RoboMaker Fleet Management, we provide an over-the-air deployment capability, which is integrated with AWS Greengrass. And AWS Greengrass is the one of the offerings from AWS IoT. It provides local compute, local messaging capabilities, and for RoboMaker Fleet Management, for customers who would love to use AWS Greengrass capability as well, then they can do so. So with the fleet management capability here, customers can leverage both the over-the-air deployment functionality of a ROS application, but at the same time, they can also take advantage of Greengrass capabilities. So this is how it looks like. On the top half of the diagram, that's RoboMaker's fleet management. You will first create a robot in RoboMaker Fleet Management, and behind the scene, we will create a Greengrass group for each of the robot. Then you can create multiple fleets and then add your robot into different fleets. For example, you can have a beta fleet where you organize all your robot for testing purpose, and you can have a production fleet where you put all your production robot into that fleet. And when you create a deployment job from RoboMaker, the entity will be towards a fleet. So you always deploy a robotics application into a fleet. And as I mentioned, behind the scene, it's actually AWS Greengrass resource, which you can freely access. It'll be under your account. So for those of you who would also want to take advantage of Greengrass capabilities, you can freely do so. Now let me show you the fleet management capability in RoboMaker really quickly. I do not have a hardware device here, so I will just show you the basic concept so that you know how it works. So it's under the fleet management on the left nav bar. You can create a robot. And when you create a robot, you have the option to create a new AWS Greengrass group or pick an existing AWS Greengrass group. You will assign an IAM role. That IAM role is used for the Greengrass resource on the hardware device to access various AWS service resources like AWS IoT Core or Lambda. So you will first create a robot, then you will go to fleet. You can create a fleet. You just give a name. For example, I can say webinar demo fleet. And once you create a fleet, you can add a robot to it. And one thing to point out is one robot can only belong to a particular fleet. In this case, all my robots has been assigned to my existing fleet. So let me show you one of the fleet that I created earlier. So in this case, in my fleet, I have one robot, which is my webinar robot. So every time when I do deployment into this particular fleet, it'll push to this particular robot, and I can see statistics of the deployment job. And the way you will kick off the deployment job is by going to the Deployments tab under the Fleet Management. And again, I do not have a physical robot here, but I would like to show you how it'll work. You will first pick the fleet you would like to deploy your application into, and you will pick a particular application. And for each of the robot application or simulation application you create with RoboMaker, we actually can support different versions. So as you iterate through your code, you can save multiple application versions. And here I'm just picking one version for this demonstration purpose. And then you have different settings. You can say the ROS package name, launch file, which is used to start up the ROS application. You can optionally also have pre-launch and post-launch scripts. So you can do things like to check CPU, memory, storage resource before the installation and download to make sure that everything is ready to do the deployment job. You can also do health check after the deployment using the post-launch file to make sure everything works properly afterwards. Then, of course, you have multiple configurations here. You can determine the number of like the percentage number for concurrent deployment. For example, if you set 20% as concurrent deployment, then it'll always deploy to 20% of your fleet size and then continue until 100% of your fleet robots are being deployed. You can also set a failure threshold. This becomes handy in case you have an issue in your robotics application. You can minimize the blast radius, so you can set a threshold to abort the deployment job if a certain percentage of your robots have failed the deployment. So this is the fleet management capability in RoboMaker. Now let's go back to the presentation. So at this point, we've touched up on the 4 capabilities for RoboMaker. Now I want to briefly discuss about the pricing model for RoboMaker. So these 4 different capabilities in RoboMaker have independent pricing plans so that you can use them independently or collectively. For cloud extensions for ROS, there's no additional charge from RoboMaker for whatever service that you invoke or use from your robot. You will just pay the standard rates for these each individual services. And in this case, today we support Amazon Rekognition, Kinesis video streams, CloudWatch metrics, CloudWatch logs, Amazon Poly, and Amazon Lex. For the RoboMaker development environment, again, there's no additional charge from RoboMaker. It's standard Cloud9, AWS Cloud9 pricing, which is basically you pay for the underlying EC2 resources. It'll be owned by you. And if you have any EBS storage volume mounted to that instance, you pay that standard EBS rate as well. And there's no additional charge from RoboMaker or AWS Cloud9. For simulation, it's a completely serverless model. You do not provision or manage any EC2 instances or other servers. The way you would pay for RoboMaker simulation is depending on the complexity of your simulation workloads. There's a concept in RoboMaker simulation called a simulation unit. Each simulation unit provides 1 vCPU and 2 gigabytes of memory resource. And as we run the simulation job for you, we will meter your vCPU and memory usage continuously. And for each of the simulation unit, for example, in US East Northern Virginia region, we charge 40 cents per hour. So if your simulation job, for example, use 1 CPU and 2 gigabytes of memory, then you will pay 40 cents per hour. If your simulation job, say, use 2 vCPUs or 4 gigabytes of memory, then you would pay 80 cents per hour. And it's completely pay as you go. And once you terminate your job, you stop paying for RoboMaker simulation. So for fleet management, as I mentioned, it's integrated with AWS Greengrass. And there's no additional charge for RoboMaker fleet management. Standard Greengrass rates will apply. And AWS Greengrass uses a monthly rate for each of the active device, in this case, active robots that have interaction with AWS services in a given month. Okay, so that's pricing. So we talked about RoboMaker customer. What is RoboMaker? Why you should care? We talked about the RoboMaker pricing. Now I want to spend a little bit of time to talk about RoboMaker's partners. We have Open Robotics, which is the maintainer and the main owner and distributor of the robot operating system. We have First, which has a focus on educational institution, where we're partnering with them to bring the capability of RoboMaker into the hands of students to train the next generation of roboticists. We also have a partnership with various solution integrators, and other partners to work on the ROS ecosystem, including advanced robot solutions and persistent systems. Now, in addition to these community and industry partners, we also have an education program to reach universities and research institutions so that, again, we want to provide RoboMaker capabilities to the hands of the students to be able to train the next generation of roboticists. Now, before we end this webinar, I want to have a recap of RoboMaker as a service. It's built on top of the open source robot operating system as the foundation, and RoboMaker as a service provides 4 independent yet integrated capabilities. It has a development environment in the cloud, which is where you will write your robotics application code. It has ROS pre-installed and configured, build tools pre-installed and configured, also has integration with various RoboMaker capabilities so that you can do your application development and testing through a single pane of glass. We provide cloud extensions for ROS. We provide these packages so that you can easily use these ROS packages or ROS node in your robotics application to use AWS services to build interesting and powerful functionalities into your robot without having deep expertise in machine learning and without having a significant amount of compute or storage resource on your robot hardware. We provide a simulation as a service running the cloud so that you do not need to manage any infrastructure provisioning or scaling. You can use simulation for multiple use cases. You can use it as a testing tool for iterative development of your robot application. You can use it as a continuous integration or regression testing tool to make sure every time when you have new code, new updates, the application still passes a certain performance criteria or threshold. You can use simulation to do machine learning model training. For example, you can start multiple simulation jobs at the same time to train the same machine learning model in SageMaker for faster training results, and also to account for multiple and various environment noises. Lastly, RoboMaker has a fleet management capability where you can do robot registration, you can do fleet creation and manage your robots by fleet, and you can also do over-the-air deployment security from RoboMaker Fleet Management and then monitoring the progress of your robot fleet deployment job. So with that, it concludes the presentation part of the webinar today. I want to thank everybody who take the time today to join the webinar. And for more information about RoboMaker, along with our sample applications, different resources we provide, you can visit aws.amazon.com/RoboMaker to learn more about our service. Thank you.